So I want to start today with something that, when you first look at it, feels a little crazy. We've got this pile of sources, internal projections from SpaceX, some pretty dense energy sector analysis on the U.S. power grid, and transcripts from Elon Musk's latest interviews on AI.
And on their own, they're interesting.
Ugh.
But when you put them all together,
Right, when you stack them up, they paint this picture of a crisis that I really don't think most people are seeing. The headline isn't just, Musk wants to go to Mars anymore. It's that he's seriously planning to launch the internet, or at least massive AI data centers into orbit.
it sounds like pure science fiction, doesn't it?
Yeah.
But when you dig into the data we have here, it's really a desperate infrastructure play. The sources, they aren't framing this as some grand exploration mission.
No.
They're framing it as an escape hatch. The whole thesis we're looking at today is that Earth, as a platform for computing, is basically tapped out.
Tapped out. That feels like a bit of a stretch, no? I mean, I'm looking around, the lights are on, we're building data centers constantly. How can Earth be full?
Well, it's not about physical space, it's about capacity. And maybe more importantly, it's about speed. And I think the best way to understand this is to break it down using what the sources call a timeline grammar, which seems to be how Musk is thinking about it.
Okay, a timeline grammar. I like that. So what's phase one?
Phase one is right now, today. We are hitting a hard physical wall on electricity. The demand for AI compute is just this vertical line going straight up. But electricity supply, especially in the US and Europe, it's a flat line. It's basically stagnant.
Hold on, stagnant. I mean, I see solar farms going up all the time. You hear about all these renewable energy targets. How can the grid be stagnant?
Because generation is one thing, but connecting it is the real bottleneck.
Yeah.
And the sources point to one specific piece of hardware that's causing, a global crisis. Voltage transformers.
Okay. The big gray boxes you see at substations.
Exactly. The things that step down high voltage power so a data center can actually use it. And you can't, just go buy these at Home Depot.
Right. These are massive pieces of custom industrial equipment.
They are. And right now, there is a global shortage. If you order one today, best case, you might get it in 3 or 4 years. So even if you build a brand new power plant, you literally can't plug the data center into it.
Wow.
The grid just physically cannot move the power fast enough for the kind of AI clusters that companies like xAI want to build.
There's actually a crazy anecdote in the source material about that, isn't there? It mentions xAI trying to get 100,000 GPUs online in Memphis.
Yes. And they went to the local utility, who basically told them, we can't help you on that timeline.
Because the utility is planning on a decade-long cycle, and xAI needs power, next month?
Exactly. The mismatch is total. So Musk being Musk, he says, fine, I'll just build my own power plant. They literally tried to build a gas turbine plant to power the ships directly.
Just bypass the grid entirely?
And this is where the whole Earth is broken argument really gets its teeth, because they hit a wall there too. And
Yeah.
not because of money, not a lack of natural gas. They hit a wall because of the turbine blades.
The actual fan blades inside the generator? You're kidding.
I'm not. Casting those specific metal alloy blades, it requires these hyper-specialized foundries, and the lead time to get a turbine blade cast is multiple years. The entire industrial base of Earth has just sort of atrophied. It can't support the speed of the digital world anymore.
That is just wild. So you have the most advanced silicon chips in human history sitting in a box because we can't pour hot metal into a mold fast enough.
That's it, precisely.
Yeah.
That's the friction. You have bits moving at the speed of light and atoms moving at the speed of, 1970s bureaucracy.
So his calculation, and this is all over the interviews, is that fixing the U.S. grid, rebuilding that industrial base, that's a 10 or 20-year problem.
And he needs the compute in 36 months.
So the logic isn't space is cool. The logic is Earth is too slow.
100%. Expanding on Earth is becoming legally and physically impossible for the curve he's on, which forces the pivot to phase 2 of this timeline, the 70 to 36-month target.
This is the part of the documents where I had to stop and just reread the numbers a few times. He's projecting that within 3 years, orbit becomes the most economically viable place for AI compute.
Not just possible.
Not just possible, but cheaper than building on Earth. How is that even possible? Space is supposed to be the most expensive real estate there is.
It is, but let's run the spreadsheet that he's clearly running in his head. The obvious answer is solar power, right?
Right. The sources say solar panels in space are something like 5 times more efficient.
Yeah, no atmosphere, no clouds, you get a broader spectrum of light. But even 5x efficiency, that alone doesn't pay for a rocket launch. You need something else to tip the scales.
So what is it? Is it avoiding the permits? You don't need a zoning permit in low Earth orbit?
That helps, but the real key, the insight that I think most people miss, is the battery. Think about it. You run a data center on Earth with solar. What happens at 7 p.m.?
The sun goes down.
The sun goes down for 12 hours. So if you want 100% uptime for your AI training, you need a massive, massive amount of energy storage to get through the night. You need acres of lithium-ion batteries.
Which are incredibly heavy, they're expensive, and they degrade.
They are the single most expensive line item in any renewable grid project. Now take that same solar farm and move it into a sun-synchronous orbit, where you're basically riding the line between day and night.
So you're in a perpetual sunset. Or I guess perpetual noon.
Effectively, yeah. The sun never sets on your solar panels.
Yeah.
You have 247 direct DC power from the panel straight to the computer. You delete the battery from the spreadsheet entirely.
Wow. That's the unlock. You're not just getting better solar, you are completely removing the cost of storage.
You remove storage, you remove transformers, you remove the land purchase, you remove the transmission lines. When you subtract all of that, suddenly the cost of the rocket fuel to get it all up there starts to look, well, competitive.
Okay, but let's talk about that rocket fuel part, because that brings us to phase 3. The logistics. I mean, you can't just launch a data center on a Falcon 9. We're talking about incredibly heavy infrastructure.
And this is where the entire plan hinges completely on Starship. And the numbers in the source material here, they require a total suspension of disbelief about how spaceflight works today.
The sources mentioned deploying 100 gigawatts of solar capacity. And to do that, Musk envisions 10,000 Starship launches per year.
Let's just pause on that number for a second. 10,000.
That's roughly one launch every single hour. I mean, hold on. Even if you have the rockets, what about the noise, the air traffic control, the environmental impact of launching a super heavy chemical rocket every 60 minutes? That just sounds physically impossible.
It is impossible if you're thinking about it like a space program. You know, NASA launches a few big rockets a year. But the sources are really clear. Musk isn't looking at this like a space program. He's looking at it like a commercial airline.
The airline model.
Exactly. Think about a major airport like O'Hare or Heathrow. How many heavy jets take off every hour? Dozens. The physics of launching a Starship every hour is solved if you treat the rocket like a 737. You land it, you refill the tank, you put the cargo on, and you go again.
So he's not building 10,000 rockets.
No, of course not. They'd have a fleet, maybe 20 or 30 Starships just operating on a continuous loop. The rocket is just the truck. And that shift, it changes what SpaceX fundamentally is.
Right now, we think of them as, I don't know, UPS. They deliver the package.
Right. But in this plan, they aren't just delivering the package. They own the solar farm. They own the data center. They own the satellite link, beaming the data back down. Yeah. SpaceX stops being a logistics company and becomes the largest cloud service provider in the solar system.
Wow. They become AWS, but truly vertical.
It's the ultimate vertical integration, right?
Yeah.
They don't have to pay a utility for power or a landlord for space or a shipping company for transport. They own the entire stack, off-planet.
Okay. So let's just assume for a second the airline model works. They get the rockets flying, they get the solar panels up there. But there's still one piece of hardware we haven't touched on, the actual brain, the chips.
And that's phase 4, the silicon struggle. This is the bottleneck you can't solve with a bigger rocket.
The sources mention this target of 1 terawatt of compute by 2030, which is just a staggering number. But down here on Earth, we have a monopoly problem, don't we? TSMC in Taiwan makes pretty much all the advanced chips.
And ASML makes the machines that TSMC uses to make the chips. And those supply chains are incredibly rigid. You can't just SIR the chip production. It takes 5 years to build a new fab. So if Musk needs 1 terawatt by 2030, the current supply chain literally cannot do it.
So what's the workaround this time? Is he going to build his own chip foundry in space?
Not a foundry, no, but his own design house. And this is where Tesla comes into the picture. The sources really highlight that Tesla is quietly becoming a huge player in silicon design with their new AI5 and AI6 chips.
I saw that. AI5 is supposed to hit volume production by Q2 of next year. But aren't those chips for the cars? For full self-driving?
Originally, yes. But the architecture is all converging. And this is where the sources draw this really fascinating line between the giant space data centers and the Optimus robot.
The humanoid robot. I've seen the videos of it folding laundry.
Right, but think about what's inside that robot. It has its own battery, and it has a powerful AI inference chip. The sources are suggesting that before the huge orbital server farms are fully operational, the fleet of Optimus robots will basically act as a distributed computer.
Wait, explain that. How does a robot folding laundry help train a new AI model?
It's about splitting the workload. In AI, you have training, which needs these massive supercomputers, and then you have inference, which is just applying what you've learned. If you have millions of robots out in the world, you can push the inference to the edge. The robot processes its own video feed locally.
So you don't need to beam every single thing it sees back to the mothership.
Exactly. The robot is the computer. It's a way to cheat the energy bottleneck on Earth. Instead of one giant 100 gigawatt data center, you have 100 million little battery-powered units doing their thinking locally.
So it's a bridge. It's distributed compute that buys them time while they build the orbital infrastructure for the really heavy training modes.
Correct. It keeps the whole data flywheel spinning without melting down the North American power grid.
Okay, so we've covered the how rockets, chips, solar, and the what, these massive data centers in the sky. But we have to land this on the why, because when you read the transcripts, Musk isn't just talking about business strategy. He gets, well, philosophical.
That's putting it mildly. This is phase 5, where the engineering plan merges with what you might call existential philosophy.
The intelligence gap.
Yes. He operates on this core belief that biological human intelligence has a ceiling. We run on about 20 watts of power, where AI is doubling in power every 6 months. He thinks that very soon, human intelligence will be less than 1% of the total intelligence in the solar system.
So we become the rounding error. We're the ants at the picnic.
In terms of raw processing power, yeah.
Yeah.
So his stated mission for XAI isn't just to build a better chatbot. It's to understand the universe. He wants an AI that is rigorously mathematically curious.
And this all connects to his fascination with simulation theory, right? The idea that we're living in a computer simulation. I have to be honest, sometimes I struggle to see how this actually connects to his business decisions. Is it just a fun thought experiment, or is it really driving strategy?
Oh, it's absolutely driving the strategy. You have to understand his heuristic for decision-making, which is this concept he calls the irony shield.
The irony shield.
It's the idea that in a simulation, the most entertaining outcome is the most likely outcome. If our simulation gets boring, the simulators might just turn it off or reboot it.
And being boring is an existential risk.
Yeah, that's the idea. A server farm in a warehouse in Texas. That's boring. It's efficient, but it's dull. But a ring of solar-powered data centers orbiting the planet, launched by a fleet of reusable rockets, creating a digital superintelligence to understand the universe.
That's a sci-fi movie.
That is entertainment. It makes the human story more dramatic, more interesting.
So you're saying part of the reason he's doing this is because it makes for a better story, to make our timeline more dramatic.
It sounds absurd, but it fits the pattern. It's a survival mechanism. By doing the most audacious, difficult, and dramatic thing possible, we essentially create plot armor for our civilization. We make ourselves too interesting to delete.
That is a lot to process. That we're re-engineering our entire energy and logistics infrastructure to impress the aliens watching us on TV.
Or to at least make sure that if we are in a simulation, we're the main characters. But look, even if you strip away all the metaphysics, the core logic still hold up. Earth is constrained. Space is abundant. If you want exponential growth, you eventually have to leave the nest.
It's a complete pivot, isn't it? We've spent a century fighting over scarce resources on this planet. Oil, land, water. This model is just... It says we leave the fighting behind and go where the resources are infinite.
But the entry fee is mastering the logistics. You have to solve the rocket equation before you can get to the abundance.
And you have to do it fast, before the grid on Earth chokes under the weight of the very AI we're trying to build.
That's the race. Can we build the bridge to orbit before the bottleneck on Earth shuts everything down?
So we've gone from a shortage of transformers and turbine blades to a future where starships are launching every hour to build a cloud in the stars.
It's a wild timeline. But when you look at all the constraints, it might just be the only one that actually works.
I want to leave you, our listener, with a thought to mull over. We usually make decisions based on what's safest or what's most efficient. But if there's any truth to this irony shield idea, if the universe actually rewards the dramatic and the interesting, what does that mean for us? Are we optimizing our society for safety and boredom when maybe we should be optimizing for drama and exploration? It's a dangerous thought, but maybe, just maybe, playing it safe is the riskiest move of all.
It's certainly the least interesting one.
Thanks for diving deep with us. This was a heavy one, but I think we unpacked it.
Always a pleasure.
We'll catch you on the next deep dive. Keep looking up.